your Twitch stream?
Twitch is a higher quality, I've discovered. The
Right, but
audio
mine
is
is
way better.
recording locally as well, right? So it's local on both sides. So I'm going to be recording locally. Anyway, I'm going to record my local audio on my computer. You're recording your Twitch stream, which has the higher audio quality. Although then there's going to be like a duplication because you won't be able to pull the... Never mind. I'm just going to record my audio anyway as a backup. You know what? I'm not even going to record my audio as a backup because my YouTube is a backup. Okay.
Yes.
Great. Are you ready?
Yeah.
Feels weird to not press record, that it's somehow being recorded. But okay.
Go for
Astronomy
it, dude.
Cast. What? Oh, I was just about to start. Now? Promise? Okay. Astronomy Cast, episode 552, Boyagin Star and Other Strange Stars. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Kane, publisher of Universe Today. With me, as always, Dr. Pamela Gay, senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Good. For those of you who don't know, we are in the midst of the CosmoQuest Hangout-a-thon 2019 edition. You have been streaming. You and your friends have already been streaming for, 28 hours so far?
We are at 1 day plus 5 hours, 42 minutes.
There you go. Almost 30 hours. You will be going for another 10 hours after this. And that is, of course, to help raise money for CosmoQuest and all the things that you do. So can you give, for the people who are listening to the show after the fact that it actually happened, we're still taking donations for the next 10 days.
Yes.
How can people participate and what are we looking to do here?
So what we're trying to do is raise the funding necessary that we don't have to do a lot of begging in 2020 instead of spreading the begging out over the year for all of our nonprofit efforts, which means if you donate and you're in the United States, it's tax deductible where the law allows.
501(c)(3).
Exactly. So as part of the Planetary Science Institute, we produce the Daily Space Podcast. We produce all the science projects that you see over at CosmoQuest. And all of these efforts take staff, time, money, effort. And for the past year, a lot of the people in our team have been putting in effort that they know needs to get done, that they know is the right thing to do, and we haven't had the money to pay all their hours. I don't want to do that anymore. I want to pay people for everything they do. I want to pay them a living wage. And the difference between what we bring in a standard month between donations and Patreon and everything else, and what we need to pay everyone all the hours they work is over the course of an entire year and multiple human beings, just $40,000.
Yeah.
And right now, as we record, we've raised just over 10% of that. It's not a lot, but hey, it's 1 month of me not begging.
Yeah.
And my goal is to raise this fund so that we can focus on doing science with you. We just put out a press release, and hopefully it will be hitting all of the news on Monday, announcing the names of the people in the CosmoQuest community who helped map out the sample sites that OSIRIS-REx is potentially going to go grab samples from. The names of the people that mapped the entire world, allowing us to find those safe and scientifically interesting places to explore. Your donations empower us to do this.
I mean, our goal with CosmoQuest and with Astronomy Cast and what we're doing with all these projects is to help be the connection between the people who love space and astronomy and the science researchers who are doing the work, to blur that line between who is a fan of space and astronomy and who is actually doing active research. Thanks to everyone's work at CosmoQuest, mapping rocks on Bennu, the folks at NASA were able to choose their landing site for OSIRIS-REx to be able to collect a sample and escape again. We hope, probably, if everything is if it's as safe as it looks. And that was done thanks to a tremendous effort by so many people out there.
Yeah.
And we we do this work hopefully for the benefit of all humankind, and we don't put anything behind any paywalls. We do everything out as much as we can out in the open, because education should be free.
Right.
Anyone who wants to learn should be able to learn. And
the closest we get to a paywall is telling the discoverers days or sometimes weeks ahead of the world that they discovered something.
yeah.
And that's just to allow us to get our ducks in a row.
Yeah, and the alternatives are put things behind paywalls, put a mountain of advertising and sponsorships and so on, and hopefully we can sort of find that perfect balance. And the way that works is by people supporting. So what is the URL? What is the link that people should go to if they want to contribute to what we're doing with CosmoQuest?
So if you want to contribute to the Hangout-a-thon, the best way that you can donate is to go to streamlabs.com/CosmoQuestX. This puts it through PayPal. There are no extra fees charged. And this is simply a good way to keep our accounting in order. Now, if you want more ways to donate, go to cosmoquest.org/x/donate, and you will see all the different ways that you can contribute to everything that we do.
Right on. So thank you, everybody, for your continued support through these 552 episodes so far, and all the work that's being done with CosmoQuest, and all the work that's being done with the Weekly Space Hangout. And here's to decades more. All right, let's get into this. So huge surveys of the sky are finding more and more planets, stars, and galaxies, but they're also turning up strange objects astronomers have never seen before, like Boyajian star. Today, we're going to talk about some unusual objects astronomers have discovered and why this number is only going to go way, way up. All right, Pamela. So let's talk about Boyajian star. What is it, and how did we find out about it?
Well, this is a star that we've been observing for long periods of time. You can go back through glass plate studies. And it's just a star. It hangs out. It's had slow gradual dimming, no big deal. But then when Kepler started looking at it, they realized, oh, something is going on really weird. Back in March of 2011, it was noticed that this star's brightness had dropped by 15% in a way that wasn't something you would expect from any of the normal suspects.
Right. So stars can drop in brightness on a regular basis, variable stars. How did this look different from a normal variable star?
Well, first of all, 15% is a large amount, and we see this kind of amount, but you expect there to be a certain periodicity that, while it may have variations, it's regular in shape. And it hit a dip of 15% in March 2011. It then increased by it increased by 22% in February of 2013, and it had this irregular change, and there's gaps in the observing because Kepler reaction wheels. We all know how Fraser feels about reaction wheels. But in looking at this, what we saw clearly wasn't a planet passing in front of it, because that would have been like a 1% dip. It didn't match the periodicity and the regularity in brightening and fading that we expect of variable stars. There was this slow and gradual fading between 1890 and 1990 of about 20% that just was added on to all of this as an afterthought. And all of this led to this insanity of guesswork being done, where I think every possible theory except for a giant kitchen sink was thrown out to try and explain
I'm sure there's
this
a paper somewhere that Boyage Star is a kitchen sink,
probably.
a mega sink structure.
And all of us had fun with this.
Yeah.
How did you first report it on Universe Today?
Well, I mean, for us, it's a tricky thing. So, I mean, this star dimming, the astronomers called attention to this star as a mystery, as a thing that was weird. And when they discover that a thing is weird, then they want to try and understand what's causing it. And whenever you do that, you kind of have to go back to square one and go, could it be dust? Could it be gas? Could it be some kind of variable star? Could it be some kind of interaction? Could it have rings, planets, Kuiper belts? Could it be the other stars passing in front? Could it be some kind of gravitational lensing? And then one that, gets thrown as well is, could it be some kind of intelligently created structure that's in front of it, a megastructure, a partially built Dyson sphere that's causing this dimming. No one ever believes that, but you can't rule it out. But I mean, you can never always rule out. You can always never rule out aliens, right? You can never always rule out aliens. So
it's never aliens,
but it's never aliens.
But you have to consider aliens.
Yeah, but you should rule it out, even though because it's never aliens. And so you get all of this back to square one of what is it? And then astronomers then try to fit everything. Then they do all their models. They try to fit all the stuff. And so we covered, I mean, these are some of my favorite stories to cover, because you get this time where it is a genuine mystery. And everyone just goes there's this thing, we don't know what it is. Let's find out. Let's let curiosity be our guide, and let's get to the bottom of this. And it has taken us years now with all of this stuff getting applied in different models to try and figure out what's going on, observations to chase down those ideas. And now what do astronomers probably think is going on?
Dust.
Good old dust.
So let's just run down what we thought it was and how we know that's not what it is. So one of the early ideas was that it was a regular, everyday circumstellar dust ring. So a ring of material around, I'm looking for a disk-like object. So the idea was that we had a ring of material around a central star, and as this ring of material went around and changed its inclination, it would dim that star. And we've seen objects like this before. But
it's I mean, just to give people who are trying to imagine this, right? Take a coin, spin it on a table, and as it starts to slow down, it'll start to sort of wobble around on the rim of the coin, and you'll be seeing how this coin is kind of wobbling. And from our perspective, imagine that is a dust ring. And so sometimes we're seeing the star, and then other times we're seeing this ring of dust pass in front of the star.
And the kind of repeating nature of something like that isn't what we've seen. So, okay, it doesn't appear to be a circumstellar dust ring. So then there's the idea of it's a cloud of disintegrating comets. Something shocked the solar system's equivalent of the Oort cloud, and comets went raining in. And as they block the light or don't block the light, we see the variations in the star's brightness. But with that 100-year gradual dimming, that doesn't really seem to make any sense. And how many comets does the system have, and what is causing them to keep? So it just wasn't consistent with comets being flung inwards. Worthy idea. There was the idea that it was a young star and that the solar nebula around it was still forming and coalescing, but this is an old star.
Right.
So you can't both be a young solar nebula and an old star.
Right.
There was the idea that it was a planetary debris field, so something bad happened and you have all these chunks of rocks. Different periodicities lead to different amounts of dimming, but what we saw just didn't quite, the colors were wrong. There was an idea that a planet was eaten and the star burped, but 100-year-long dimming followed by the brightening and dimming.
Right.
There was an idea that there was a ginormous version of Saturn orbiting it, and the oscillating rings of this ginormous Saturn is an eclipsing binary. But they couldn't make the math work on it because there's this 100-year dimming beforehand.
Yeah.
So then you start like trying to add different periods. It just, no.
Right.
That it was just the star does it. But we've
but star does it, but why? But why does the star do it, right? Like you can't just say star does it and then because that's like aliens did it. Like what is the mechanism?
Yeah. So people tried to figure out, is it star spots? Is it, and just none of our theories worked. My favorite is the artificial megastructure. I actually got to sit on a panel at Dragon Con with Larry Niven and talk to him about this.
Oh my God. Ringworld.
And yeah, but the issue was that, so you explain the gradual dimming as they build the structure around this. You explain the variability as different inclinations of the structure that is incompletely built. Mm-hmm. But you would expect certain notches out of the colors of the star if you have a structure, because the structure would be blocking most colors of the light,
right?
But then radiating away infrared.
Right.
It's warm, and we don't see that infrared overage, that infrared excess that you would expect from an alien megastructure.
And just momentary rabbit hole for a second, that is a technique that astronomers have used to go looking for megastructures. Like you do a gigantic survey, like the WISE survey of the entire sky, looking for really weird infrared stars. And that's what a megastructure, a Dyson cloud would look like. And astronomers haven't seen any.
Which is people frustrating.
Are really saying, like, well, what if the aliens are blocking the infrared radiation? That's heat. If you block the infrared radiation, you just cook.
Yeah.
It's called an oven, and you're in it. So you got to get that infrared radiation away. And so they have to release it in some way, shape, or form. And so we would be able to detect it. And so this is one of the things, one of the methods of SETI. Astronomers have looked hard for both entire galaxies covered in Dyson spheres and in individual stars within the Milky Way. And so far, nothing's turned up. And we would see them. But anyway, I digressed in a fun way. Back to the story.
And this is where it came down to lots of people combining lots of observations. We had folks spelunking through the historic literature, through the glass plates, looking for old observations, everyone trying to put all this data together. And what was eventually found is there are changes in color that people screwed up the maths initially. So one of the early papers that came out was this can't be dust because the color is wrong. Again, looking for that infrared radiation of warm dust. Right. The color was wrong in an initial paper. And when the work got redone, they found that yes, if you look at it in one color, you see one amount of dimming. If you look at it in a different color, you don't see the same dimming because that infrared radiation is letting more of the starlight come out and the warm dust is radiating light. Right. And so it turns out sometimes it takes more than one person to do the same kind of research. It takes more than one telescope. And it takes a lot of years. It was only in 2017 that people really started to accept the idea of, oh, yes, this is actually dust. And it took observations that here is what it says in the original research paper, This chromatic extinction implies dust particle sizes. So this is the colors of light that are blocked.
Right.
Implies that there is 1 micron dust. And that dust will be rapidly blown away by stellar radiation pressure. So the light from the star is blasting this dust away. So the dust clouds must have formed within months. So this means there are things that are currently coalescing these dust clouds. The modern infrared observations were taken at a time when there was at least 12.4% plus or minus 1.3% dust coverage. And yada, yada, yada. And this is consistent with dimming originating in circumstellar dust. So there is a ring of dust around this star. It's getting blasted away, recoalescing, getting blasted away. And this process, which isn't periodic, is dimming the star in some colors and not others in a way that allows us to actually figure out what size the dust is.
Wow. And since Boyajin star, and the name comes from the researcher who helped identify this.
Yeah.
Yeah. The astronomers have since found other potential candidate objects that are kind of similar and behaving in the same way, right?
Yeah, there is a whole set of them. And they all have esoteric numbers. So we have HD 100543, HD, they all have HD numbers. Yeah. And these are protoplanetary systems in most cases. And it's that difference between it being a young star and this one being an older star that led to the confusion. But there are these rare instances of stars doing weird stuff out there. One of my favorite weirdo cases is our Corona Borealis stars. These are stars that periodically undergo dramatic dimming events that are very characteristic because the stars apparently periodically sneeze dust, and all this dust blocks their own light. And so we're finding a new class of star. And what's amazing is if the Large Synoptic Survey Telescope manages to come on next year, as we hope it will, it's scheduled
2021.
It got bumped again?
No, 20. I thought it was 2021. If it maybe first test 2020. Anyway,
first light 2020, full survey mode 2021.
Okay, all right.
We're both right. That's nice. It's nice when we're both right. When it comes
that was a very nice way of saying that you're wrong, Fraser. Please continue. I'm probably wrong. I'm probably wrong.
So when LSST comes online, it is going to start ramping up towards burying us in new kinds of stellar variability. Fully operational in 2021, it will be covering the entire sky every few days as visible from the southern hemisphere. And they're expecting potentially millions of transient events every single night.
Yeah.
As the telescope spots things that flicker, flare, fade away, and move in our sky.
Yeah. We had a similar situation with Henny's Verwerp. We talked about that, many years ago on multiple occasions. And you sort of started to talk about this with the LSST. Astronomy is kind of changing where these sorts of objects are now going to start turning up, right? I mean, we're entering the realm of giant surveys.
And the way to think of this is, if there are no purple M&Ms except at Easter, if there's one purple M&M for every million M&Ms made, and you randomly are gifted bags of M&Ms by random people, I want to be you, first of all. Second of all,
M&M recipient.
Yes.
Not a sponsor.
Second, as you go through these M&Ms, you're probably not going to encounter that purple M&M unless you're really lucky. Well, our sky is huge, and as we work to study it, fainter, more distant, rare objects may not get readily uncovered.
Yeah.
This star just happened to be in the Kepler field.
Right. And that's the key. It's a
Yeah.
fairly small field of the sky.
But it had a huge number of stars in it. And so we're looking at what, 1 in 100,000?
Right. And so I
And
think that's the part that's super interesting about this, is that we've seen variable stars. I'm sure the first time someone saw a variable star, like they said, like, that's weird. And then what causes a star to change in brightness over the course of a couple of weeks? That's madness, right? And now we see them all over the place, and we use them as measuring sticks. We see stars that are giant and red. We see stars that are dim and red. We see stars that are different colors. So a lot of the regular stuff has been seen, and now we're looking for the weird stuff. And it's these giant surveys that are turning up these weird candidates. And that story of Boyajian star is, like you said, right? You getting a purple M&M in your, and like, how did that happen? And you got to like, you call them, the factory, and you find out that at one point someone did it as a joke, or maybe someone,
the Easter run got mixed in with the regular
M&Ms.
M&Ms.
One got left out, and there's like an explanation, but it's going to take some more time. And so we're now finding all the weird edge case scenarios, which is really exciting.
And I do need to give a shout out to Astro YYZ and Keeper of Maps, 2 of our audience members who have sent me both maple cream cookies, a Canadian delicacy that was sent to the ISS, but before that ever happened, was my favorite kind of cookie, as well as Canadian Kit Kats, which don't have corn syrup in them in the same way, and Smarties Canadian style, which is my husband's favorite candy. So Annie's going to get to try them, and then I suspect the rest will be stolen.
That is so funny.
I did have a candy fairy that may have inspired that analogy.
Can confirm. Those are Canadian things.
Yeah. These rare stars, they can be rare for 2 different reasons. One of them is they could be rare because it's a very short-lived phenomena. So if you think about it, it is only for the briefest moment in time that your average human is doing certain things. We all at one point or another are going to choke on a glass of water. Let's face it. It's not that rare. I've probably misswallowed something once per year, and here is Fraser drinking and testing fate.
Yeah. We don't breathe our liquids.
But accidents happen. Now, the average person observing me is not going to ever see me choke on water, because it's a brief thing that's going to happen. But all of us in our lives are going to eventually see one person in our life choke on a glass of water, because human. But there's other things that we do are much more rare. Not everybody, but some people have the misfortune of actually like choking on something solid and needing the Heimlich maneuver.
Yeah.
And in my entire life, I have only once ever needed to use the Heimlich maneuver. And most people will never have to use the Heimlich maneuver.
I haven't yet.
Good.
Yeah.
And so that's a very short-lived phenomena that is both short-lived and rare, which means having it occur is not something that's typically going to happen. Now, that moment that a helium flash occurs in a star, that moment that so many things we probably don't even know what are happen in a star, is short-lived in the grand span of how long stars live. And so the probability we will be looking at the right star at the right time to catch this short-lived event is low. So we're going to miss a lot of short-lived phenomena. And then there's just going to be weirdo stars that do weirdo things across their entire life, but they're few in number. Yeah.
I mean, think about a supernova, right? A supernova is a very rare event, a star that has survived as a star for millions of years, reaches the end of its life and detonates and is gone in a flash. And we see them out there all over the place across the universe. And yet, if you compare those to the rarity of other things, they would be incredibly rare. But it's because they're very bright. And so we see them. And so we're now going to see the things that are very rare and not bright.
Yes.
And not easy to see. And that is, and we are going to learn as much from these new objects as we have from the bright ones, from the supernova, that just happened. We happened to notice them first because they were, a star many times the mass of the sun, detonating in a moment and gone and turning into a black hole. I can't wait. This is we're so close to seeing data come out of the LSST and these other sky surveys as well. W first, and what TESS turns up, and what the Gaia survey turns up. Yeah. Plato, Cheops just launched. Cheops? Anyway, people give me a hard time.
Yeah, still working on the pronunciation of that one.
Yeah. So we are it has never been a more exciting time to be following the latest stuff on astronomy, and we'll of course bring you many, many more of this every week, especially next week, maybe. And I don't know.
Yes, until then, and this is a hint, that thing that you're wondering why we aren't talking about it, next week we'll talk about it.
Yeah, the Betelgeuse thing?
Yeah.
Yeah, okay. We could also talk about the Starliner not making it to the International Space Station, but maybe not.
Things to look forward to 2020. Is it actually making it next time?
Come on, Betelgeuse. I love it.
So before we go, I do need to thank our Astronomy Cast Patreons. So this week's people that we're going to thank are Glenn, Bubba, Samuel, Joshua Pearson, Dustin, Ralph, Joe Wilkinson, Brian Kilby, Chad Colopy, William Lauer, Jeremy Kirwin, Mark, Stephen Raznak, Jay Alex Anderson, Brent Kreinop, Omar Del Rivero, Tim Garish, Tyron Fong, Arthur Lotz Hall, Dave Gates, and Neuter Dude. Thank you so much. You and your patronage at patreon.com/astronomycast keep this show going. And if you want to help CosmoQuest, we are continuing to try and raise money. We're going to still be doing it after the new year. You can go to streamlabs.com/CosmoQuestX to help out with the, overall administration of everything we do.
Thank you, Pamela. Thanks, everyone. And we will see you all next week.
Bye-bye.
Have a great Christmas.
You too.
If you celebrate it. And if you don't, Festivus for the rest of us.
And enjoy the discount candy.
Sounds good. All right. Happy holidays, everybody. We'll see you next week.
Bye-bye. And I want to thank, before we go to questions, scrolling. Thank you, Kevlar, for the 1,000 bits. And I saw a donation come in, but trying to not look sideways while recording the stream. Where is it? Thank you, C Possum 8404 for the $49.94. You donated a palindrome. Did it make our overall donations a palindrome again?
So
I love palindromes, people.
That's awesome. That's so clever.
So we are at 4099.98. Can someone make that a palindrome? It seems like it would be easy to make it a palindrome. You do the math.
I love it. All right, let's give some questions. So Yuval Litvin asks, why is Betelgeuse supposed to explode or shrink?
Well, Betelgeuse is a red supergiant. It is a massive star that has already gone through its initial stages of evolution. It has puffed out. It has had some gradual variability. The atmospheres on stars like this, the outer layers of the atmosphere, are actually thinner than the Earth's atmosphere, so it's really hard to understand what mechanism is controlling their pulsation at this period. At this point in its evolution, and down in its core, it is running out of fuel to sustain its nuclear burning. And when it runs out of fuel that produces energy when fused, it is going to collapse. And this collapse is going to trigger a bunch of different things that include the explosion of the star as a supernova. Exactly how it goes from the star it is today to that exploded future, we don't fully know, which is part of what makes Betelgeuse's current dimming so exciting.
How different is Betelgeuse? And I mean, obviously, this is a preview of what the show is going to be next week. Yeah. How different is Betelgeuse to just like the sun?
I like orders of magnitude. I I don't remember its exact mass, but I know it's currently hanging out bigger than Jupiter.
Right. So it is a star. If you
That
dropped Betelgeuse in the solar system, it would extend out beyond the orbit of Jupiter.
yes.
It is dozens of times the mass of the sun. It is on a completely different trajectory than it's only a few million years old, and it's going to explode and be gone, probably leave a black hole when it's done. So,
Yes.
and we don't know when it's going to happen. It could happen. It could be happening right now, or we might still have to wait another 100,000 or a million years for it to explode. Not many million years though.
No,
It's a goner.
It's a goner. It and Ada Carina in the Southern Hemisphere. And thank you, Mike Ease for Sheezy for the 200 bits. My dog is like, wait, you said thank you. Does that mean I get a treat? Yes.
Is that your dog your dog's trigger now is to like hear you say thank you?
Yeah, every time I say thank you, my dog comes over and then demands treats. Look at the camera. Look over here. See?
That's really clever.
Come up. Look at the camera. Okay, here you go. And there's another dog. Awesome. It's okay.
Yeah, we can't do that with my deaf dog.
There. Hi. Okay. So these are my doggos. Malachi.
But our dog has gotten pretty clever. She even though she is deaf, she started to make some clever observations. Like she can tell when the kids come through the door because the light changes in the house a little bit. And she can see that just subtle change in light. She can feel the footsteps in the house when people are walking around, and she knows when you can get her attention by just stomping on the ground.
Oh yeah, we had a deaf dog for years, and we'd do stuff like that. Yeah. And have you had to do the resort to waving a flashlight to get them at night?
No, I haven't tried. Like your phone, that would work.
Yeah. So we've reduced to extreme because our dog was also nearsighted and deaf. So extreme motions were required. Yaviltfin asks, could it be that it would shrink into a kind of black hole? So Betelgeuse, I don't remember if its mass is big enough that it could leave behind a black hole, but a black hole is one possible result of a supernova. We will prep for next week's episode and figure out during prep just what awesome sauce is possible.
Yeah, black hole or neutron star, something that's going to leave some kind of remnant. OG Pyro asks, so is all the stars in the galaxy like the ones that were big enough to turn on, and then we have 80% that were not big enough to turn on?
Not quite. So here the idea is when you have a cloud of dust and gas, it will collapse and fragment, and the majority of those fragments are probably going to not turn into giant stars like Betelgeuse.
Right.
There's a what's called an initial mass function of stars, where the bulk of your stars is going to be the little red dwarfs. The minority is going to be the massive stars. And what we don't know, because they're really hard to see, is what number of the stars are brown dwarfs that maybe fuse lithium for a small period of time, maybe fuse tritium for a small period of time. What we don't know is what ratio of the objects are that tiny. But it wouldn't, as far as we know, because I'd expect that we would have been able to tell by now. As far as we know, they're not going to dominate greater than the majority. Right. There could be a significant number of them out there, but I don't think it's going to be that many.
Yeah, it's just a standard mass distribution curve, right? That you get a couple of, just think about money on Earth. You get a couple of people with a ton of money, and then you got to get a bunch of people with, middle class, and then a lot of poor people. And that's how it works in the universe too. You've got these stars that have gobbled up all the space money, and they're going to explode very quickly. And then you've got a middle class of stars, the main sequence stars, and then you've got a lot of people who don't have a lot of hydrogen money. This analogy is falling apart.
Well,
Gordon
it's just
asks,
gotten very sad because at the most impoverished level of both, you just die because you can't feed yourself
well,
and you
but
don't have enough mass to actually coalesce into anything.
I guess so, yeah. But the smallest red dwarfs live forever, pretty much. So,
Right.
like I said, the analogy is starting to fall apart here.
Yeah.
But Gordon asks, could Betelgeuse die without going nova? So,
No, not that. Well, it could undergo a massive amount of mass loss in a way that we don't understand
right.
over the course of a large number of years. Mass loss is one of those things we're still trying to figure out. But unless some sort of completely not understood mass loss event occurs, it
Well,
has
there are
enough
these
mass, it's
unnovas,
going.
right? There's these unnovas. So there's a situation where the star just like, you know, in a star like Betelgeuse, these large stars, they are forming all of these heavy elements in their core, and they're building up these layers. And then at a certain point, the outer layer becomes iron, with the inner layer. So the inner layer becomes
Yeah,
iron,
the
and it
core.
stops fusing in its core, and then all these outer layers just collapse inward, and then it forms some neutron star or black hole, and then the rest of the layers are thrown out into space. But it looks like there's a lot of them that just they suck everything in, and so it fully collapses, and so that it was a star, and then it's just gone, and it's
And
because it
that's
was too good of a black hole.
and this is a completely new idea that I have to admit I'm still wrapping my head around and still trying to figure out. Okay, when does what happen?
Yeah,
And
well, nobody knows.
yeah,
Yeah,
and with things like that, there's so many things we don't fully understand. We're working on trying to understand, and how things die star wise.
yeah,
Uh, we're learning so much now that we can do what's called multi-messenger astronomy, where we're detecting things through particle physics, through gravity waves, as well as through the electromagnetic spectrum with light and radio telescopes, which just detect a different kind of light. It's kind of amazing.
I
Can't
see that
complain.
your next crew have shown up, so I
They
need to give you some
have.
time to get that all organized. So is it time for me to leave?
Sure.
Okay.
The reason I say it like that is you leaving means I can turn over this channel to Nancy, Sondy, and Morgan, and
Yep.
I can go take a break. So for the next hour, we are going to have some of our good friends from the Weekly Space Hangout crew here to, well, talk science. So Fraser, do you have any parting words? And can you please tell all of our CosmoQuest people who are still getting to know you where all they can find your stuff, including your award-winning guide to space that just keeps earning all the awards because it's awesome.
Yeah, well, the guide to space shows up on my YouTube channel, but the place to go for all the things is just my website, Universe Today, universetoday.com. Universe Today on Twitter, Universe Today on everything. And I think we wrapped up episode 421 of the Guide to Space, and we do two of them.
Wow,
We try to
you've
do
been
two of them
doing
a
that
week.
quickly.
We work quickly, yeah. And I just wrapped up my 112th 11th question show.
And Infinite Oregano just donated $11.16, making us a palindrome again.
Once again, man, that is smart. Oh, I'm gonna steal that idea.
I just love palindromes.
I know. It's a great goal. It's a micro goal to help keep
Yeah.
things a palindrome. I think it's really smart. But yeah, so and then the other thing that's thanks to and I keep saying this, but now it's like a promise, thanks to good friends at Oceanside Photo and Telescope. The telescope is working again.
Good.
And we were going to try and bring it tonight, but now it's cloudy and rainy where the telescope is. So,
Right.
but it's Dustin upgraded the camera on it and upgraded the focuser on it, and it's a monster. Like, it's already just a monster, and now it's a super monster. I can't believe the quality of the pictures I'm taking in. Like a 30-second image of M33, like of a spiral galaxy, that is just as good as stuff you would do for hours in the past. It's unbelievable
It's
how good this
amazing.
is. So I can't wait to share this all with you. So stay tuned, both here on Twitch and on my YouTube channel for a lot more telescope streamery.
Awesome.
Okay, well, I don't think I'm going to see you until, well, I guess we'll see you next week. And then after that,
we'll see you in person in Hawaii in just 2 weeks.
In Hawaii, yeah, exactly. I can't wait.
So have a fabulous holidays, and may we get a supernova.
Yeah, that'd be great. All right, thanks. And hi, Morgan and Sondy and Nancy again. I'll see you later.
Okay.
Bye everybody.